Hey, my awesome advanced algebra students. We are going to do 6.3 piecewise functions, and this lesson will be due Wednesday night, and then 6.4 will be due Friday night. So, piecewise functions. A piecewise function is a function that is a combination of one or more functions. The rule for a piecewise function is different for different parts of the domain. You probably are confused by that definition, but I think you'll be like, oh yeah, I've seen this before. So one thing I do with my class when I actually have people in it is I ask them for examples like movie ticket prices. Okay? But I think I will just go ahead and make my own piecewise function and pretend like you guys are helping me out. Okay? So piecewise function looks like this, where there's a rule here and a domain here. Rule, domain. And it can be 2 equations long. It can be, 10 equations long, whatever. But let's talk about movie ticket prices. So, let's see. If you are over, let's say under the age of 10, you're paying $6. So, 6 if x is less than 10. Now let's say you're between the ages of 10 and 60. Then you have to pay $10. But once you hit 60, then you only have to pay $8. So this is kind of what a piecewise function looks like. So I go to movie theater. If I'm less than 10 years old, I only pay $6. If I am 10 or 20 or 30 or 59, I have to pay $10. And once I hit 60 or older, I only have to pay $8. And that's kind of real life stuff with that. I'm sure there's better examples out there, but this is something that I've done for years. So the fact that these are constants and not a rule makes it a step function. So this here is a step function, and I have this cute, it took up a lot of room. But isn't this cute? Walk like a step function. See? So, yeah, okay, sorry. I got kind of stuck with looking at that. So let's take a look at this step function and see if you can read it. Okay? So we have mixed nuts and the price per pound. So if you have a weight of less than 2 pounds, you need to pay $8 for every pound you have. If you get to the counter and your weight is at least 2 pounds but less than 5, then you're going to be paying $6 per pound. And if you purchase mixed nuts and you have 5 pounds or more, then you'll be paying $5 per pound. We're going to go through some examples. This was just kind of introduction here. So evaluating a piecewise function. To evaluate any piecewise function for specific input, find the interval of the domain that contains the input and then use the rule for that interval. So here is a piecewise function with rules and not just constants. Yeah? It says evaluate the piecewise function for when x is -2. So what you need to do is you need to take that -2 and think, okay, look at the domains. Does -2 fit into this one or this one? Is -2 less than 5 or greater than or equal to 5? Well, -2 is less than 5. So we're going to use this rule, 3x plus 4. And we just plug that -2 in to that x. So we have -6 plus 4. So evaluating this piecewise function for -2, you're going to get -2. F of -2 is -2. It doesn't always work out like that. Let's take a look at when x equals 5. So if x equals 5, then I need to use this rule because it fits into this domain. Okay? So I have x squared minus 3, and I have to plug my 5 into that. So I have 5 squared minus 3, so I have 25 minus 3, so I have 22. So f of 5 equals 22. This just takes a little getting used to. It's not too bad. Let's take a look at this one. This one is a step function because these are all just constants. Okay? So we need to find h of -1 and h of 3. So let's look at -1 first. -1 fits right here because it's more than -3 but less than 6. So h of -1 is going to be 15. And h of 3, well, 3 is in between -3 and 6 as well, so that is also going to be 15. Nothing too exciting. Let's look at the next one. We're going to evaluate this for g of -1 and g of 4. So -1, that happens to fit into the first section because x is less than or equal to -1. So I'm going to use the 2 to the power of x. So I'm going to use 2 to the power of -1, which is 1/2. G of 4, well, 4 is greater than -1, so I'm going to use this rule, which is 5 times x, or 5 times 4, which is 20. So in this case, g of -1 was 1/2, and g of 4 was 20. One more slide to go through. Graphing. And this, of course, is the most difficult part of the lesson. So it's just graphing, but you have to be aware of the domains. So a lot of times I teach it by just graphing this rule and graphing this rule and then worrying about the domains and going through and erasing. So we can do that. Let's graph -3x. Okay, so let's think y equals -3x. How would I graph that? Well, the y-intercept is 0. And my slope is -3, so down 3 to the right 1. Down 3 to the right 1, or up 3 to the left 1. Up 3 to the left 1. Now I'm going to draw this, but I'm going to be aware of my domain. So this line only matters. It's only a line. It's only visible when x is less than 2. So let's find when x is 2. Well, when x is 2, here's this line. So I'm going to put an open circle here, and I'm going to go this way. Wow, that's pretty rough. Okay. It doesn't even exist when x is equal to or greater than 2. So I use an open circle because this is open. This is just a less than. Now when I graph x plus 3, I have my y-intercept at 3, and I'm going up 1 to the right 1, and so forth. And that only matters when x is 2 or greater. So when x is 2 or greater. So I can erase these other dots. not that. No, not that. Oh, there is an undo button. Nice. I gotta redraw my line here. Would be nice if I could actually draw it. All right, so this is what this piecewise function would look like. Okay? If your value is 2, you need to use this. If it's greater than 2, again this. If it's less than 2, it's going to look like that. Here we go. This one is going to be a step function because you have constants. So 4, remember when y equals 4 or y equals -2, those are just horizontal lines. Okay? So I'm going to go ahead and go y equals 4. 1, 2, 3, 4. I'm just going to draw it all the way across right now. And y equals -2. Yeah, what the heck. Now, I do need to start caring about the domains, however. So, this 4 only matters when x is less than or equal to -1. So, anything greater than -1 can get erased. And because it's less than or equals to, we're going to use a filled in circle. Likewise, -2 only matters when it's greater than -1. So anything less than -1, whoops, that'd be right here, doesn't matter. And because it's less than, we need to put an open circle right there. And that would be a wonderful looking step function. Simple, but it still works. This is a more complicated one, so we'll see how well I can draw this on this thing. You have a couple quadratics and linear. So I will just write these out so I can see. Y equals x squared minus 3. Y equals 1/2 x minus 3. And y equals x minus 4 squared minus 1. I'll do this one in purple. So x squared minus 3. Well, that's a parabola, but it's down 3. Okay? And you can always plug in numbers. Wow. I'm concentrating really hard on this. All right. Then let's graph this 1/2 x minus 3. So here's my y-intercept, and I'm going up 1 to the right 2, up 1 to the right 2. And I'm going to kind of draw a line. Okay, and then in blue, I will do this one. So this is vertex form, which means my vertex of this quadratic is going to be 4, -1. All right, and it's also the parent function moved to the right 4 and down 1. So 1, 2, 3, 4, down 1. Yep, that's the vertex. And we'll just kind of okay. Now let's worry about the domains. I'll get my handy dandy eraser here. Okay, so this purple one, this first one, only matters when x is less than 0. Okay, so we are going to erase it all for anything greater than 0 of that purple one. Okay. The green one is only good between 0 and 4. So 0 and 4. Oh, I should have drew that better, I think. But anything more than that or less than that, doesn't matter. I'm going to redraw that line a little bit. Okay, so it's an open circle there and it's a closed circle here. And lastly, the blue one only matters for greater than or equal to 4. So I'm going to go in and I'm going to erase anything less than 4 for the blue one. Well, I'm having troubles with this, but you can see it's going to be kind of curved here. Should be straight throughout the green, and then it's going to be curved again. It's really funky looking, and that's probably, you shouldn't have any that difficult. By the way, if you need graphs and you can't print any out and you don't have any left over from the project, I do have some sitting at my spot at the school where you hand in things. So feel free to grab what you think you'll need for the next couple weeks or whatever. And if you take the last one, please kindly let me know so I can fill her up. Well, that's all for 6.3. Let me know as you have questions, and I'll move on to 6.4 for next time.